Okay, let's summarize this topic. So we saw several types of imitation learning approaches. The first one, the straightforward one is behavioral cloning, where we're trying to minimize the loss, the difference between the actions provided by the demonstrator and the actions that are provided by the policy that we are training. But we're minimizing those over all states that were observed by following the demonstrator. This can work well when the state distribution that we obtain from our policy we train, is the same as the state distribution as the demonstrator, but it works horribly wrong where this is not the case. We see different states under our policy compared to the demonstrator's state distribution. Then we saw direct policy learning as a simple way to address this, where we use an interactive demonstrator to shift from the state distribution provided by our demonstrator to the state distribution, or to training on the state distribution provided by the policy that we're actually training. So this is very effective. By the way, if you have an interactive demonstrator, Dagger should be your go-to algorithm. It works very well, although it's from 2011. Yes. From 2011, but still it works very well. There's no... usually you don't need a lot of other improvements. It's a very good solution. However, it requires an online demonstrator, which is not always available. Then we discussed... What did we discuss? The inverse reinforcement learning. We assume that we are able to learn some reward function, and we assume that learning this reward function is statistically easier than directly learning the policy. And when we do that, then we can optimize. We learn this reward function, we optimize our policy using reinforcement learning. On this reward function, we compare the two policies, and we always make sure that our constraint on the reward function holds. If it doesn't hold, we update our reward function. Then we discussed the maximum entropy approach, where we're simply trying to fit the trajectory distributions while having a policy that provides maximum entropy over these trajectories. Finally, we discussed GATE, generative adversarial approach, which learns to trick a discriminator such that it won't be able to discriminate between the policy that we are training and the demonstration policy. And these are the theoretical attributes provided by each of these approaches. So, behavioral cloning and interactive imitation learning, they provide direct policy learning. They're trying to directly fit or doing supervised learning on the policy, while inverse reinforcement learning and generative adversarial IL imitation learning do not perform direct policy learning. Inverse reinforcement learning is the only one that tries to learn what motivates the demonstrator agent, what makes it tick, what are the objectives of the demonstrating agent, and then optimize the policy on that. All of these imitation learning algorithms perform online learning. They assess some access to the environment. The only one that does not require that is behavioral cloning. We don't need to interact with the environment. All of the training is performed offline. Maybe for testing the policy, we'll need to go online and test it in the real world, but for training, we don't need any access to the environment. The assumption of an interactive demonstrator, which is a big assumption, doesn't always hold, that only applies for interactive imitation learnings, but for the other approaches, we don't require this very strong assumption. If you do have an interactive demonstrator, you should use Dagger. Else, well, you need to use other of the other options that we covered. However, the other types of imitation learning approaches, they all require some pre-collected demonstrations, while Dagger doesn't necessarily require that. I mean, it can be used to speed up the process, but it doesn't necessarily require it. You can just perform online learning by observing, by querying the demonstrator. Okay, so these are just the links to all of the papers that we discussed in this topic. So at this point, we're already diverged from our textbook. And this is why I'm providing you this reading list, reading materials, just the full description of the algorithms that we covered. And next on our agenda would be we already did transfer learning. So next on our agenda, I'm sorry about that, next on our agenda would be derivative-free, black box optimization. Assignments, please be sure to be on top of your assignments. At this point, you should probably be implementing your DDPG agent and A2C agent. Quizzes, there's an available imitation learning quiz on Canvas, and you should already have taken or completed, hopefully complete very soon, the soft actor critique quiz. And with respect to the course project, you should be starting to finalize, working on your final report, hopefully at the later stages of that. That's it, thank you.